Chapter 9 is all about molecular geometry and the different bonding theories that have been developed to help explain how molecules, how their shape is, and how they take up space. So far what you've learned with regards to how molecules are made is the Lewis theory. So Lewis theory, basically what you have is, if I have a molecule like CH4, we count the electrons, right? We say that carbon has 4 valence electrons and hydrogen has 1, and there's 4 of those, so there are 8 total electrons. And we build our skeletal structure where we have our carbon and our hydrogen. And this is correct in the sense that carbon is bonded to 4 hydrogens in single bonds. But when we draw on paper, we are limited to 2-dimensional space. So we need another model or theory to help us predict how the molecules are arranged in 3 dimensions. Since Lewis structure does not. But luckily for us, we will use Lewis structure to help us determine the shape. So basically we're going to be building on every time we talk about a new theory. We're just going to build on from what we just did. So in a molecule, there are both bond angles between the atoms and bond lengths. For the most part, the way we drew it with the Lewis model makes it look like the bond angle between those 2 terminal atoms is 90 degrees. But we know that these bonds here are made out of electrons. And electron pairs in bonds and when they're lone pairs, they're going to repel each other. Because the electrons repel each other, this leads scientists to develop the valence shell electron pair repulsion, or VSEPR model. And so basically what this says is that the electron pairs that are in the valence shell, right, the ones that are actually doing the bonding, they're going to want to get as far away from each other. So when I just have 2 electron groups here, the furthest away they can get from each other is 180 degrees, making that molecule look like a line or linear. When we have 3 electron groups, right, so this could be an atom like this or an electron pair, to get as far away from each other, we get into a bond angle of 120 degrees or trigonal planar. Once we get 4 atoms around the central atom, we have to start to break into 3-dimensional space to get the optimum amount of spacing, and that's called tetrahedral, where our bond angle is 109.5. Tetra means 4, and hedral means side. So if we were to put sides between these 3 atoms, there would be 4 sides. It's like a 4-sided die. When we have 5 terminal atoms around the central atom, we'll talk more about this in detail, but we end up getting something that's called trigonal bipyramidal with 2 types of bond angles, 90 and 120. And when there are 6 terminal atoms, we call that octahedral or 8-sided, and that is 90 degrees all around. We want to think about not only the atoms that are around the central atom, but also the lone pairs on the central atom.